The National Spatial Reference System is the foundation for surveying and mapping and GIS for the US. It is the official reference system and the math and science behind how to position ourselves on the planet, and how to know where things are. Basically, latitude and longitude and the height system for the country.
Hello, I'm Sylvia Oakland, and this is GovCast. In February, I attended Esri's FedGIS Conference here in Washington, D.C. I was fortunate enough to speak with Galen Scott, the National Geodetic Survey Constituent Manager at NOAA, to learn more about how he and his team are modernizing the National Spatial Reference System, or the NSRS.
So we started in 1807 when Lewis and Clark came back and Thomas Jefferson said we need to make maps of the coast. So for many generations we were the U.S. Coast and Geodetic Survey. And now we are within NOAA, we're the National Geodetic Survey, and then also part of that history is our Tides and Currents groups at NOAA and the Office of Coast Survey. So historically we've kind of worked really hand in glove together. We provide the foundation for all federal maps, and that mission has gone back all the way to 1807, right? It's that important. It's a nation-building science to be able to map and understand where things are and such. So we've been developing these reference systems for 200 years. The current one that's in place, they're called the datums, and that's the North American datum of 1983 and the North American vertical datum of 1988. Right? So yes, they go back to the 1980s. And what's important about that is that those two systems that are currently in place, currently the official datums, right? When you do a base flood elevation for your house, you have to measure that above NAVD 88, right? Those were made in the 80s with the best technology at the time, and they were based on 100 years of survey measurements that had been taken place by our crews, literally walking across the country and taking these measurements. And one of the issues with that is that over that 100 years, the Earth changed. But because it was such an enormous effort to do all of that surveying across all the whole country, there were a lot of places where we only measured it once, 80 or 90 years ago, and that data was used to build the system that we use today. So the Earth changed over that time, so it didn't really account for that. So that's one of the things that's really driving the new system, is to create a new system that we can update with the Earth as it changes.
Right, so looking at both data modernization and some of that tech modernization coupled together to make sure you get a more holistic picture of what's happening across the U.S.
Yes, absolutely. And now that we have GPS, right? So GPS was actually my office. Our scientists brought GPS to the civilian surveying population, right? They figured out how to get around the Defense Department's selective availability and made it a surveying tool for surveyors now. And now we all have it in our cell phones. Right?
No, that's incredible. So what has this prep work looked like? There's so much data, as you mentioned. And we hear that before we can use any sort of AI, before we can use any sort of these new emerging tech, we have to have that data in a good position. So what has that data modernization kind of looked like? Where have the challenges been, and what are some opportunities that you're looking forward to?
Yeah, so the two current systems, NAD 83 and NAVD 88, were built separately. Separate surveying crews walking across the country using different technology. One doing angles and distances, and the other doing what's called geodetic leveling to measure height differences. After those were released in the 80s and the early 90s, then GPS came along. And GPS was a real disruptive technology, and it took, I like to say, we had to MacGyver it or jerry-rig it to the current systems to work with GPS. So we were able to do that, but it wasn't the best solution. And now the new system that we're building is based completely on GPS, right? You're going to be able to get your positions with GPS. The big impact of that is that it used to be surveyors, when they wanted to start a new road or a new subdivision or something, they'd have to go find one of our survey marks that we had surveyed to get their point of beginning and their coordinates, and then they could survey off that to stake out the subdivision or whatever. The new system, so that was limiting. You had to go find one of these marks that we put in the ground. Now you'll be able to use GPS and get a position wherever you need it. The other big thing so the founding of using GPS is a big change. But the other thing that we've been working on for 17 years, we were flying airborne gravity data collection. We collected airborne gravity data over the entire United States, all of CONUS, all Alaska, and all the territories. And we took that gravity data and created a new model of gravity called the geoid model. And it's enormous. It covers the entire northwestern hemisphere all the way across, and then 2 smaller grids out in the Pacific for American Samoa and the Marianas. But what that does for us is it gives us a consistent surface across the entire country, from coast to coast, across all of the rivers, and even across the coastlines and the shorelines out into the oceans, which was a limitation of the current system, because geodetic leveling, you can't level over big bodies of water. So now that it's based on a gravity field, it's going to improve things like modeling, coastal modeling, because you have this system that goes over that land-water interface.
Wow, so the system is both going to integrate technology that we've had for a little bit, but also kind of add in some of those things that we haven't seen before, and really empower those who are using this technology and these data sets to make better decisions faster.
Absolutely, right. So geodetic control, the data that we're talking about, is the foundation for all other federal data, right? You have to reference it to a system, and ours is the system that the federal government is required to use. So we have made it a little more challenging and a little more complex to do that over the years, because we have been changing it and updating it to work with GPS, and as we got new data and stuff. So we kind of created a Frankenstein's monster by incrementally improving things over the last 30 years, which, if you talk about datums, knowing which datum you're in and what version of NAD 83 you're in can be a challenge. This new system will wipe the slate clean and will give us all one new system that everybody can use, that will be able to be updated with time, which is what caused us some issues in the past.
What are some next steps that you're looking to? What are some milestones we can see coming out of the NGS office?
Sure. So right now we have the definitional products on our beta sites, and they've been out there for several months, so we're going to lock those down in the near future. And then coming up in the next several months are a whole series of tools that people can use to use those models. Those tools will be on beta for 6 months or so, and then probably early next year, we're looking to get the whole new system adopted as a standard by the Federal Geographic Data Committee. And once it becomes a standard, then everybody is supposed to follow the standards. So looking forward to next year is when we're looking to make it actually official, and we'll replace the current datums in 2027.
Well, we will be looking out for that in 2027. Galen, thank you so much for joining me today on the program.
My pleasure. Thank you.